Hello, my name is Eli Damolo, and this is an addendum to the project that I already submitted in class. In the class submission, I was not able to demonstrate or show some of the results here. So this is not a complete recording here. This is just adds up to additional information that I previously presented in the class presentation. So this portion is only going to add to what I already presented. So please refer to the original presentation. So what I want to show you in the demo part of this project is I created, like I mentioned before, I created a project that involves getting information from a ticketing pricing website, and this ticketing pricing information then goes through Kafka, which I already discussed before. The data comes every 80 seconds, so it gets aggregated. Aggregated, and then it goes through some of the data aggregated data goes through Postgres, and then goes to the UI. A portion of aggregated data goes to the Cassandra database, which also goes to the UI for additional analysis and so on. And then for long-term storage, we send the information to S3 buckets. The reason why we use S3 bucket for long-term storage is because using standard databases can be very expensive because you run those on, say, EC2 instance or something like that, but S3 is just basically files. So I did all this already in the previous presentation, and also mentioned in the previous presentation that we set up the configuration using Docker, and here I'm just going to show what the Docker file looks like really quickly. That's the Docker compose file, and it consists of the zookeeper there that I mentioned, Kafka, some Cassandra configuration, and so on. Again, all this code information will be available with the code. So just to walk through some of the Python code really quickly before I do the demo, we have here the Kafka producer, which again it's just an application written in Python. It does some reads information from the API. That's what I'm showing here. It generates the quotes, it creates a Kafka instance, and that Kafka instance then creates some brokers and so on. It does it captures information, and then it creates the ticket and key value pair, right? So that's what that is, a producer. Again, it's just a Python code with some special library called Kafka, right? But the rest of it is just started, having knowledge of the library and then using it to generate stuff. So that is that portion over here that I'm showing here. The Cassandra consumer, again, it is just another Python code, and here I'm going to show what it is. It's one of the consumers. Like I mentioned, we have two consumers. We have the Cassandra consumer, and then we have the Postgres consumer. So in the Cassandra consumer, you have that, and again, it just sets up some data centers and sees if it's available. It creates a table, and then it just consumes the information that comes from Kafka. And you can see again, we're using the library, special library called Kafka, right? But again, once you know the library, the rest of it is just standard library Python code. We show here the consumer, which is a Postgres consumer, and that would be this section here, the post aggregation stuff, and that's what this is. Again, it sets up the progress configuration, tests things in progress, it does some verification, and then it creates the data. Here we use the structure called for the structure for the database users. We use the two schemas. So we use not the stack configuration, but a different configuration that kind of normalizes the database. Snowflake Fleamer, that's what it's called, Snowflake schema. Anyway, so that does that part, and that's what we create here. So we create tables that are sort of joined together, and if we look at the database itself, To look at the database structure looks like, I'll go back here. That would be under, we have that another web app here. If you look at the configuration, we see here in the models, this is where we create the different tables. We have the city, we have the place type, we have, so it's essentially we use that. It creates the snowflake structure, and we showed that here under the Django, right? So if you go back here again, that's the section here. So we use Django to create these different tables that I'm showing here under the models of Django here. Anyway, so that's this section here. We talked about the Cassandra. We talked about we'll go over the UI in a minute. For the S3 side, we show here an S3. That information comes through when the producer is created. So we see under the consumer here, that's the Kafka producer. You can see it reads information and then it sends stuff to S3 file as JSON dumps. So that is that for this section. So once the information is collected on the UI, we then create pull information using two ways. One option is to use Dask UI. The other option we used as well was REST API. We just tried different options just to see how they measure with each other. So we'll go back to, and we did this portion of the implementation. We did this with all with Django. So if I go back in here again, go back to project structure, go back to where the Django is. Django is under web app, and inside of web app we have the data app, which is, we did some configuration stuff here. You can see the different things we did here with setting up the Postgres and so on, setting up different things, authentication and so on. Anyway, so under the application itself is where we are. We've created the views. There's only one view called Chat API, which is what this is. So there's one view that we view. We created a class. We're using class-based views here. Actually, we use a combination of both. We use ticket APIs, which is what we're using here. So the ticket API gets information in two ways. It runs, it gets the results, get API destination, and this information comes from using a class that we created from using Dask, right? So we have some serializers here that we use, and then we have our views here, right? So the views, if you go to the price ticketing API, that's what creates this other table here, ticketing API, and this uses Django. This uses Dask, right? So if you look here on the Dask, we have it starts this library called analytics, and it pulls the ticket prices over this distance. That particular API is what we show here. If you go back on analytics, we use analysis option here, and we write some queries here that do the pulling of the data using Dask, right? So that's what this section here is. And then finally, the other section. So with the Dask, once we have the information, we display here. So in the display, we use back to the views again. Under the view section, we have everything's under Django here. We have the views. So the views captures information. Like I mentioned, this information comes from Dask UI. It creates we have a serializer that we created earlier. We have a form that we create using forms. Check if the form is valid, we clean the form. If the serializer is valid, we return the context. If it's not, we return the HTTP request. So then this context here then goes to the chart, which is now under data, and that is under templates, and we have a chart here. So this looks at the context. That's what this is. We have some CSI stuff, CSS stuff, using we also use this is the actual UI, the page that is showing here. Anyway, so it gets information. It looks like we have a JavaScript function here that runs, checks, pulls information from our API which we created earlier. It extracts some information and it creates the UI that we see. So anyway, this is the end result. I'm running out of time again. Here we show a plot of, it is an actual plot. You can see the information here. If you refresh the page, we should get new data. It shows a graph of real-time information, number of flights coming in from different airports, and also we show average pricing. So the end of the goal of this exercise was to see how do we leverage, for this class specifically, how do we data stream, get information in real time, aggregate them. That's something we cover in one of the classes. How do we store them in database? How we use serializers to serialize information, show them an UI. We use some coloring here. So we exploit use of color, we exploit use of Django, we exploit use of Dask UI, we exploit use of Django ORM. We've showed the use of SQL Alchemy as well. So we pretty much cover 90 or more of the stuff that we covered in class. Thank you for taking time to listen, and have a nice day.